Good morning. My name is Natalie Lawson. I'm going to go over this bioimage analysis guide that I made for the Fish Harbor Lab. And yeah, let's get into it. So the purpose of this project is to automate an analysis workflow to identify, classify, count, and measure the foci and anaphase bridges in the Fish Harbor Lab fluorescence microscopy images. Um, Here is a section of fundamentals. So this is good for anyone who, like me, who was a beginner who didn't know anything about bioimage analysis. I recommend you look at all these resources. So this is a book, an online book, a GitHub book that has a lot of important information or just basic information. So, for example, this section goes over images and pixels and what they are. And then this section is processing and analysis, which is essentially what you're doing, which is a good, I think you should read through all of this. And then this is about fluorescence microscopy, and that's very relevant to this project. And then that's it. This is a very short book, but it's very important and informative. So ImageJ or Fiji is the basic software that you're going to be working with most likely. And I also explored Cell Profiler, which is, I think you should work with both of them. There's a lot of other softwares, but I think based on the limited things that I did, Fiji and Cell Profiler are the most relevant. Um, so this is not really super necessary for you, but this is the open source code for ImageJ. So if you're a coder or someone who knows coding, um, this is something you can use and maybe modify. But you don't need to do that. If you don't know coding, that's fine. I don't. ImageJ, this is a user guide, so this is kind of like a car manual. So anything and everything is in here. Every tool. It will tell you how to use it, where to find it. And so I recommend you going back to this user guide if you get stuck. But first, I recommend you going through YouTube's. Go through a bunch of YouTube's um, tutorials and then try it out for yourself. And then go back to the user guide if you need help. And then this section is probably the most useful to you. So this is the help section. So image.sc is essentially Reddit for bioimage analysts, and it's a very tight online community, and you can get any of your questions answered. I recommend maybe subscribing to their email list because you can see other people's posts and they're probably asking similar questions to you, and you can learn from the people who respond to them. And I think you should read through my posts, so I linked them here. Um, in July. This was my first post. And then Bram van den Broek responded to me. We had a good thread, and essentially we learned that Stardist and Cellpose are the two plugins that you should really explore for this project. Stardist is a pretty easy plugin to install. He linked it right here. It's for Fiji, and it helps segment the cells like this. And then Cellpose is probably going to be helpful for the anaphase bridges because it can possibly adapt to the weird shape. Um, but it requires a Python virtual environment, and setting that up for me was a little tricky. That's where I got stuck. So maybe you can uh, try that, continue trying that. And then, yep, I recommend you read all of this. And then my second post was in September. And from here, I got this recommendation to segment the cells in Fiji and then export the image out of there and import it into Cell Profiler, where we can identify the objects and measure and count the cells, which would then spit it out into a spreadsheet. And I think that's a very good workflow because you're you're gonna be using the softwares to their advantages and using just what you need. It's try to keep it simple as possible. And remember for this project specifically, you're not be as exact as possible, but overall Fish Hopper is looking at trends rather than um exact numbers. So, for example, that's relevant in segmentation. Maybe it's not going to be perfect, but almost perfect is good enough for segmentation. And then Koba is another online resource. The thing I find helpful about this company is that you can click on the Collaborate tab and then sign up for their office hours, and that is where you can speak to experts who do this for a living and online or live. So you can share your screen over Zoom, and um, I did meet with them, and where we left off is that the images I was using, especially because as you'll see later, when we open them in Cell Profiler, it's quite dim, and that is kind of the problem with this project. But if we can't identify the foci manually, then it's going to be really hard to teach the computer to do that. So I'll touch more on that later. And then this YouTube playlist, I really recommend you go through this. So these are just tutorials that I accumulated, and they're all very helpful, and it tells you everything you need to know. And then um, so the software you're going to be using is Fiji and Cell Profiler. I provided links to the downloads right here. Make sure to download for your software, so Windows or Mac. Sorry, I don't know why I'm tripping on my words today. Cell Profilers right here. You can download here. And then, so here are links to the plugins Stardust and CellPose. And I also attached YouTube videos that will show you how to install those. And so overall notes on this project, I think I did this too late in the game, but you should catch another lab member who is used to manually identifying the foci and the bridges and have them walk you through the process. And once you can manually identify, it'll be a lot easier to try and identify it on the software because you need to see it. And so in relation to that, the model images that I used were Hafrida's trial 1, I think, and they were tagging DPB11, and it was just really too dim. So I think you should use a model image that it's tagging something other than DPB11. Um, because it was just too dim to see the foci. It was just a little too hard to identify. That could have been due to my lack of skill on these softwares yet, but I think if you start off with an image that was clearer, then that might be helpful. Use a lot of practice. So I'll show you with Cell Profiler and Fiji, there's a lot of tools they provide to practice on, and that'll help you get familiar with the software. And then, and again, like I said, the proposed workflow that I think you should go forward with is try to segment in Fiji and then identify, count, and measure in Cell Profiler. And then, so special challenges with this project are that each of the foci in these images are probably going to be different brightnesses. Um, the distinguishing parameter is that they are a difference of 50 from the background. So it might be hard to, teach a computer to look for that. So, and then the anaphase bridges are unique and elongated, whereas most of these softwares are used to pretty much just round cells. And so that's going to be a challenge. But I think cell pose is a good start. So now let's open up the actual softwares. Um, okay, share my screen. So this is Fiji, and I'm gonna open up an image. So I'm just gonna show you the interface of these things, and I'm not really gonna go through any processes because I think the YouTube tutorials I provided are enough. But I will show you how to open these images. So you can go to plugins, bioformats importer, or you can just drag the image there. We'll open up the CZI file. Okay. And so here's the 4 channels and the Z slices. We can uh, split the channels and we can look at the brightness. So for example, this is just if we split the channels, this is one of them, and then you can scroll through the Z slices. And so this is Fiji, right? And then if you want to practice, I think, right, images. Hmm. Okay. That's okay. The most important, so there's practice images here somewhere. I forgot exactly where they are, but the videos will show you. And I think what's more important to practice is Cell Profiler. So let's open that. Okay, so here where it says try example, more examples, and tutorials, Cell Profiler has a lot of tutorials. They essentially come with PDF instructions and then timelines, and then there's a bunch of YouTubes that follow those tutorials. So it's very easy to get to know this software. Um, Here you're gonna double click here on drop files, and let's just open. So I recommend splitting the CZI in Fiji, segmenting it, exporting a single channel as a TIFF, and then opening it in here in Cell Profiler. And so you can see that's the image I just imported. It's just the channel 3. If I double click on it, it'll show this image in grayscale. And grayscale is good for analysis. And then this is where you're going to add your modules. And so, for example, identify primary objects, double click. And so what you want to develop is a whole pipeline of these kind of commands, and then you're gonna press. So to test it, you should do test mode just to test each of those steps. But once you're ready, press analyze images, and then you'll just have this like pipeline that you can dump any image into, and the analysis will run through all the images, and then you can especially add this module, data tools, export to spreadsheet, and it'll export all your data into a Excel spreadsheet. And I think that would be very helpful. There's a bunch of YouTube videos on this, and yeah, so I think that's about it. If you want to reach me, my CSUN email is natalie.lawson.208@my.csun.edu. And yeah, that's it. Thank you.